In this video, we are going to talk about how to identify a function as even or odd. So in previous lessons, we've talked about the leading term, and we looked to see if the leading term's exponent was even or odd. But now we're going to be talking about the entire function, and we're going to be figuring out if the entire function is even or odd. So if we look at this first one, it says, how do I classify a function as even or odd when given a graph? Some functions can be classified as even or odd. You can determine whether a function is even or odd by its graph or by using algebra. An even function is a function that is symmetric across the y-axis. That means if the point xy is on the graph, then so is the point negative x, negative y. An odd function is a function that is symmetric about the origin, meaning that you did a reflection over the y-axis and then a reflection over the x-axis. This means if the point xy is on the graph, so is the point negative x, negative y. So down here we have some examples of even and odd functions. Let's say that this is the point xy. Then this point over here is the point negative xy, making it even. And then over here, if this is the point xy, then this is the point negative x, negative y, making it odd. So you can either imagine doing the reflections to figure out if it's even or odd, but most students find it easier to just apply the rules that are given to see if it is even or odd that way when you are given a graph. So down here it says determine whether the function is even, odd, or neither. So to figure it out, what I like to do is I like to just pick a point. Doesn't matter what point you pick on the graph. I'm choosing this one right here. This is the point 1, 2. For this point to be even, then that would mean that the point negative 1, positive 2 would have to be on the graph. Because remember, for even functions, if you have to given the point xy, then you also need the point negative xy. So is the point negative 1, positive 2 on that curve? No. So it's not even. Let's see if it's odd. Remember, if it is odd, if you choose the point xy, then the point negative x, negative y will also be on the graph. So if it were odd, then the point negative 1, negative 2 would be on the graph. Is this point on the curve? No. So this graph is not even and it's not odd, so our answer for number 1 is neither. Let's look at example 2. On example 2, again, it doesn't matter which point you pick. I'm just going to pick a point that falls perfectly on the graph. So I'm going to choose this point right here. Actually, let me choose that point in purple to be consistent. So if I choose this point, this is the point 1, negative 2. If this function were to be even, then that would mean the point negative 1, negative 2 would also be on the graph. Is the point negative 1, negative 2 on the parabola? Yes, it's right here. So this is an even function. If we look at the next one, for the next one, I'm going to pick a point. Doesn't matter which point you pick. I'm going to pick this point right here. This is the point 1, negative 1. In order for this point to be even, or this graph to be even, then the point negative 1, negative 1 would need to be on the graph. Is this point on the curve? No. So it's not even. Let's check to see if it's odd. If this graph is odd, then the point negative 1, positive 1 would be there. Because you have to change the signs of both, right? X was positive, now it's negative. X was positive, now it's negative. X was positive, now it's negative. x is negative, so we need to switch it to positive. So -1, +1, is this point on the graph? Yes. So that makes this an odd function. So if neither of the rules work, then it's neither. If you are able to apply this rule, that makes it even. And if you are able to apply this rule, then it is odd. On example 4, it says, if -3, -6 is a point on the graph of an even function, then what other point is on the graph? Well, I know that for even functions, if I have the point x, y, then I also have the point -x, y. So all you need to do is just change your sign of x. So if I change the sign of x, the point 3, -6 would also need to be on that graph if it were even. On example 5, if the point -2, -5 is a point on the graph of an odd function, then what is another point on the graph? Well, I know for odd functions, if I have the point x, y, then I also need to have the point -x, -y. So you just need to change your signs of both. So -2 is negative, so I gotta make that positive. 5 is positive, so I need to make that negative. So if the point -2, 5 is an ordered pair on an odd graph, so is the point 2, -5. Down here we're asked, how do I classify a function even or odd when given the function? So if you're not given a graph and you're just given a function, how do you find it? Well, you can identify even and odd functions by looking at the exponents. If all of the exponents of the variable are odd, then the function is odd. And if all of the exponents of the variable are even, then the function is even. So they all have to be odd or they all have to be even. If you have a mixture, then it's neither. So down here it says determine whether the function is even, odd, or neither. On example 6, the exponent of my variable is 2. This is the only exponent. 2 is an even number, so that makes this even. On example 7, I have 2 terms, each with a variable, so I'm going to have 2 exponents to look at. For 2x cubed, my exponent is 3. What is your exponent for x? Your exponent for x is 1. Remember, we're looking at the exponents of our variables. If you have x, that's x to the first. If you don't have an x, right? So if you have 3x, then it's 3x to the first. But if I have just the number 3, then that's like 3x to the 0th power. So here, my exponents are 3 and 1. 3 and 1 are both odd numbers, so that makes this function odd. If it helps, note that 0 is considered to be an even number. Let's look at the next one. We have x squared minus 3. For x squared, my exponent is 2. What is the variable of x for the -3? Well, there is no x there, so it's like you have x to the 0th power. So here, your exponents are 2 and 0. This is considered to be even because 0 is considered to be an even number. And then on example 9, 13x to the 4th, there my exponent is 4. plus 2x. What is the exponent of x here? 1. Plus 12. What's your exponent for x here? Well, that's like x to the 0th power. So here my exponents are 4, 1, and 0. Even, odd, even. When you have a mixture, your answer is neither.